Section 2.7, Math 110, it's inverse functions. If you find two functions, f of x and g of x, that f of gx is equal to x and g of fx also is equal to x, then under those conditions, we just say function of g is inverse function of function f. And there is an example here. In this example, we have this function of f of x. We want to know which one of these two functions are inverse of that. So first, we try fg of x. So you understand fg of x. Fg of x means take g of x, which is this, and substitute for x in the fx functions. Put it right here, replace that. We do that and we see the answer is not x, it's just something like 25 over x minus 12. So obviously this is not the inverse of that. Now we try f of hx. F of hx means take hx, which is this, and take the whole thing and substitute for the x here. So we do that and we end up having the x. Now to verify, you also need to find h of fx. Means this time you take f of x, you take the whole things, and you substitute for the x here on hx. And then you end up having x. So basically we prove that f of hx and h of fx both are x. That means these two functions, fx and hx, both are inverse function of, or one is inverse of the other one. So that's how we find the inverse functions. All right, now there are two ways to find the inverse function. One is by method of graphing. So here, this is the original functions, f of x is the yellow one. To find the inverse of that function by method of graphing, first you have to draw bisector of this angle. This angle is 90 degrees. So bisector of this angle means is a line of y equal x, that divided into 245 degrees. So you draw that line, and then you find reflection of or symmetric of this graph with respect to this line. When you do that, you find a new graph, which is this piece. This is the inverse function. And the symbol we use for inverse function is f with the power of negative. But that doesn't mean that you have to take the function raised to the power of -1. This is just a symbol we use, f of -1. So any point on the original functions, if you switch x and y or a and b, that gives you a point on inverse. So if you have a bunch of functions on this, let's say you have a point on this, which is 3 and 5, that point when you reflect it is 5 and 3. By swapping the x and y. So any point x and y on this graph would be, when you swap it, would be a new x and y here on this graph. So here, this is another example. You have this line. This is the original line. To find the reflection, we draw the bisector, and reflection of this would be that line. And how do you do that? You take a point, you draw the perpendicular line, and you extend it with the equal distance to find the new points. Okay? See? Original point was 2, 1, right? With that point, when you draw the line and continue, that give you 2 and 1. See, all you need to do is swap 2 and 1. That give you a new pair of point on the other one. Like here, original one, this point is 1 and -1. On the inverse is -1 and 1. So we just swap these two. This is another example. You draw the bisector. This point, when you draw the line, vertical line, and you extend it, that gives you another point. So 3 and 9 now is 9 and 3. 2 and 4 is 4 and 2. This is the original function. This is the inverse functions. And then later on, we show you how to find the equation of this one. You know how the equation changed from y equal x2 to y to gx equal y equal x. We show you how to use the algebra to come up with the equation, with the inverse equation. But when we give you a graph, how do you know this graph does have inverse function now? One method is method of vertical and horizontal line. Means you bring a vertical line and you move this vertical line from left to right. If intersect the graph at only one point, then it passes the vertical line. And then you bring the horizontal line, and if the horizontal line cross the graph at only one point, then this graph passes vertical line and horizontal line. So it does have functions. The second graph, it passed the vertical test. If I draw the line, a straight line, it intersects the graph at only one point. But it failed the horizontal test because it would intersect at more than one point. So a graph has inverse if pass horizontal and vertical line. Passing means when you bring the vertical line or horizontal line extended like that or like this, it should not intersect the graph more than one point. Like this one. This one definitely has an inverse because whether you do horizontal or vertical, intersect the graph at only one point. Let's say you have this graph. This is your function of f of x. We want to know whether we do have inverse or not for this one. First, you do the vertical test. Vertical test, you bring the vertical line. See, vertical line intersect at more than one point. So it failed the vertical test. It doesn't have any. This is graph of y equal absolute value of x. It passed the vertical test because it intersect at only one point. But it failed the vertical, it failed the horizontal. See, if you go to horizontal, it intersect at more than one point. So it's not the one-to-one functions. In order to be one-to-one function, it has to pass vertical and horizontal tests, both of them. They call it one-to-one function. The only function that have inverse are one-to-one. Like if you have a function which all these points are -2, 4, if you want to find the inverse, all you need to do is just swap these two. See, these are the point on the inverse of this. How do you find the inverse functions? First step is in the original function. See, f of x equal that means y is equal to this. So what you do is you swap x and y. So instead of y, you put x, and instead of x, you put y. See, that's what you do first. Then when you cross multiply and you isolate y, the new one is the inverse functions. So what you do is you just switch x and y, and then you try to find y in terms of x. That is your inverse functions. This is the graph. Does it pass the vertical and horizontal test? Yes, it does. Look, when you draw the line here, it passed the vertical and also it passed the horizontal test. I'll show you here. See, it passed the horizontal test. And this is another example. See, why is that, right? So what I do is I swap X and Y here. Instead of X, I put Y. Instead of Y, I put X. And try to work on this equation and write Y in terms of X. This is your inverse functions. See, and it passed the vertical and horizontal test. Okay, so then on this example, we show you how to find the vertical and horizontal test. I did a solution here for you. See, you swap X and Y and write Y in terms of X. But here, they want us to find the inverse function first and then prove that these two are inverse. Remember, the proof is this. You must prove that f of inverse of X is inverse of fx, and both are equal to X. Means if you have, when you find this one, this is the inverse, right? And this is your f of X. Now, if you want to prove that these two, this is f of X, this is inverse of X. If you want to prove that these two are inverse, you got to do this to show that both are X. Second example, first you find the inverse by swapping X and Y. You find your Y. This is your inverse functions. This is your fx. This is your inverse. Function inverse. Now you want to prove that these two are inverse of each other. You got to prove that this is X. The other one also is X. X and X, okay? They all are very similar. We need to prove that fgx equal to g of fx, okay, and is equal to X. Now this is your original functions, right? If you want to show graphically, what would you need to do? Don't you put the bisector first? You graph the bisector and then you find the reflection of this to that, right? And that's we came up with these answers. Because if you find reflection of that, then you see something like that. So if this is your f of X, this is your inverse, okay? This is your bisector. This is line of y equal X. So you graph your line of y equal X and you find reflection at every point. And that gives you the new graph inverse, which is this one. How do I find the inverse of that? Again, graph the bisector here. And then this is what you see. Something like this. So you find the mirror of this with respect to that line, it gives you something like that. And I think for number 7, so number 7, 8, and 9, you have the solution. I'll show you how to do the algebra for this. Number 7, 8. They all are here. See? These are your functions. You get to prove that f g x and g of x both are x. Now here, remember the inverse means if you have 3 and 6, the other one should be 6 and 3. But we don't have. When you plot this, there are several ways to do it. One is you plot this to see what you have. And when you graph it, you see a curve that it failed the test. Or, so here, like 1, 2, 3, 1, 2, 3, 4, 5, 6, 4 and 3, 5 and 2, 7 and 6. It just gives you a graph which it failed the test. Does this have inverse? Yes, because it would pass the vertical and horizontal test. See, either test would intersect at only one point. This one failed the horizontal test. It passed the vertical test, but it failed the horizontal test because in the horizontal test, it intersects at 2 points. So it doesn't have any inverse. And here, I'll show you how to find the inverse. You just swap x and y and find the y. And then you could answer the questions here. Original function is 5x minus 2. Any number you substitute for x, you always have a y value. So this kind of function that is not a fraction, neither fraction nor radical, domain is all the numbers. Range also follow that. This one too, look. There is no, this is just a normal line. It's like 0.2x plus 0.4, see? Y is equal to that. So it doesn't have any denominator with the x on it. Domain and range is all the numbers. All the linear equations are domain and range is all the numbers. This I'll show you how to find the inverse. And this is a quarter of the circle. And remember, they are saying x is always between 5 and 0. X is always between 5 and 0. So when they ask for the domain, remember, you have it here. And the domain and range, and both functions are almost the same thing. See here? This was f of x, right? What is inverse? Same thing. You have the same equation. So obviously, domain and range of both are the same here. When you find the inverse, this is the inverse. And then when they ask you here, domain and range. First, what is the domain and range of this? Because this is a fraction, what number would make the denominator 0? 2. So you don't want that. So domain is all the numbers all the way to 2 and then start from 2, not 2 itself. That's why we have a parenthesis. Inverse function, what number would make the inverse function undefined? 1. And also it's like that. So x cannot be 1. And here x cannot be 2. Y equal x4, it failed the horizontal test. If you graph it, y equal x2, y equal x4, and they all are kind of very similar graph. It just X4 is skinnier. But it failed the horizontal test. So that's why it doesn't have any inverse. If you use a calculator, 13 over x2, it give you this kind of graph. It failed horizontal test. And this is how to find the inverse. X over 8, this is just like 1/8x. It's just a straight line. So it does have an inverse. Y equals -9. P of x equals -9 or y equals -9 is horizontal line. And it failed the horizontal test. You know what? If you bring a horizontal line here, it touched this at so many points. So all the line of y equal a number, they failed the horizontal test, so they don't have any inverse. Let's try to find the inverse. This one, when you graph it, you see this. See, if you use the graphing calculator, we give you something like that. So you see that it would fail. It would fail the horizontal test. Because horizontal test, horizontal line intersected at more than 1 point, so it failed. That's how to find the inverse. So I put a solution for all this. One thing you need to know here is they ask us to find domain and range, right? You find it. For inverse, all you need to do is remember what's the main difference between a function and inverse? You swap. So domain of function is range of the other one, and range of f of x is domain of inverse. So domain of fx is range of inverse, range of fx is domain of inverse. See, you always swap. You know how we say if you have a and b on the main function, on inverse is b and a. See, domain and range now is domain and range of the inverse functions. Then here, when you find the domain and range, all you need to do is take the domain of this, make it range for this, range of this, domain for that. Same thing here. Domain is range of that, range is domain of this.